Hi there, and thank you for clicking on this lesson. In this lesson, we're going to address the question, what are logarithms? And try to ground a sense of what they are, where they come from, and what they do. Please give this video a thumbs up if you find it helpful. Subscribe to the channel for more math content. Drop a comment. Let me know what you think or if you have any questions. And check out the many other videos and playlists on the channel. Usually I write there to be sure to check out the practice set, but this particular lesson does not have a practice set to go with it. So feel free to hang out on the channel and check out the many other things that we have. I will be sure to link some of those at the end. Now, we want to start this with looking at the graph for y equals 2 to the x. And what I want to do with this is to just establish a firm base for where we are and what we are working with. So that is an exponential function where we have the variable in the exponent. And in this case, our base is 2. I'm going to come back to that vocabulary in a bit. Here's a table for finding some of the points. So we have a value for x and the corresponding value for y that goes with it. So when x is 0, y is 1. When x is 1, y is 2, and so forth. You'll notice that my x values are counting up by 1, starting at 0, and my y values are doubling each time. And that doubling comes from the base of 2. We are multiplying by 2. Now, I can generate that table by simply picking a value for x. Say x is equal to 2. I plug it into my equation there. So x is equal to 2, and that makes y equal to 2 squared or 4. And you can do that for any amount of numbers. So I just picked a sample of numbers there to throw into a table. Now, because graphs are the way we visualize the data, it is useful to look at the function graph for that. So on this graph, we have the individual points that I picked. So I think I had a collection of 5 points. You can see those with the big purple dots. But just because I picked integer values from 0 to 4 doesn't mean that I was restricted to that. I could have picked a 5. I could have picked a negative number. I could have done 2 to the negative 1. And so what we do is we connect those dots and we represent the values in between with a solid line, and the fact that it goes off the coordinate plane I have available, we put the arrows there. So I could have picked 5, okay, and come over here, and the 5 would have been up here somewhere, okay, 2 to the 5th power would put me up at 32, wherever 32 would be. So there are more values on that graph than we have represented with the points. Notice the shape of the graph. It actually starts out looking really, really flat. And the further you go to the left, it's going to look super, super, super flat. It's never going to be negative because I can't take a positive number and raise it to a power and get a negative number out. And then once it starts to curve, it gets steeper and steeper and steeper, and it gets really steep really fast. And that's part of the nature of the exponential graph there. Now, suppose we wanted to find the inverse. Now, why you would want to find the inverse depends on the context, and there are plenty, like actually tons of applications of this, and sometime future to when I am recording this, I will record a video looking at financial applications and some of the money equations we use to like find interest. To clarify it, that is, suppose we needed to find the value of x that would give us a needed value for y. So let's just say we're going to have this come up later. All right. So let's say I knew that I needed y to be 10. What value of x would give me that? Okay, and you can rewind the video if you want, but that's not on our table, and we don't want to play guess and check for too long. So let's take a look at the algebraic process for finding inverses. And there's a whole video lesson on this, so if you need to click and find it, you can go ahead and do that. But I am going to link a different video into this one. So anyway, I'll link the video for finding the inverses in the description, not the comments. I could put it in the comments too, but I'll put it in the description box if you would like to check that out. Okay, so for finding an inverse, typically we want to switch our inputs and outputs. So I want to have some kind of function that will take that 10 and tell me the value of x that goes with it. And so we're switching the x, the inputs and outputs, the x and the y. And so that gives me x is equal to 2y. And now we're kind of stuck. Okay, so what we need here is we need a way to get this y out of the exponent. Okay, because otherwise I am just like stuck here. Like how do I get this y out of this exponent so that I can figure out what it would be? And so here's our need. Subtracting undoes adding and vice versa. So you know that if you have something being added and you want to undo that, you would just subtract. And or vice versa, you have something subtracted and you need to undo that, you would add. We know that dividing undoes multiplying and vice versa. Okay, they're what we call inverse operations. We know that square rooting undoes squaring. So if you've got something squared and you want to figure out, well, what number squared gives me this, you would take the square root of it. And notice a little bit of a change in the vocabulary there. I could say we square root it, but the way I phrased it was we take the square root. So I just want to call your attention to that slight change in how we say it because it's going to apply here as well. So we need an operation that undoes the base of the exponential. In other words, if I have this 2 to the some power, I need a way to undo the base of, in this case, 2, but just hypothetically, if you had a 3 or 4 or like anything else, you would need a way to undo that. Like, how do I undo the fact that I have raised the 2 to a particular, I've made the, there's not a great way to phrase it. Sometimes I'll coin the word exponentialize, like we exponentialize the y, meaning we like put the y into the exponent, but I'm not totally sure that's a word. In short, we need a way, an operation that's going to undo the base of that exponential and leave me with the y. And that operation is called taking the logarithm, okay? And it introduces the concept of the log. Most of the time when we're dealing with this, we would just say log and not logarithm. So log is short for logarithm. And notice the phrasing there. We don't like log it, we take the log of it. So it is an operation that we can perform on the 2 to the x or 3 to the x or whatever it is that will undo that exponent. So here's what it looks like. We need to undo the specific base of the exponential, in this case a 2, and we're going to use a log of base 2. So the base of the exponential is the base that we need to undo. And just to review, looking at the vocabulary there, this is the base of the exponential. And this right here is the base of the log. And the way I would read that is log base 2. Okay, and you'll notice that the 2 is a subscript. Okay, it is written smaller and slightly below the level of the log. So if the log is on like the main line, the letters log, the 2 is going to be smaller and slightly below. It's the opposite of a superscript, which is what an exponent is. The exponent is smaller and written slightly above the line. This is going to be a subscript, and it is read out loud, log base 2. A log of the base 2 will undo the base of 2 on the exponential. If you had a base 3 on the exponential, then you would take a log base 3, and you would take log base 2 or log base 3 or log base 5, whatever, of the exponential, and it will undo it. So what does that look like? So suppose I have a 2 to the x, okay, and I want to undo it. What I would do is, introducing our new operation, I would take log base 2 of 2 to the x, and that would undo it and give me the x out. Now, this might seem really, really out of the blue. Like, well, but what is it? What is it? It's a new operation. So if this is the first time you're encountering logs, or maybe you've encountered them in a class, like, once, and you're clicked on this video to try to clear up the haze, it's going to feel very uncomfortable. But think of the first time you used a division symbol, and so you had done something to like illustrate what division is, and then the teacher would explain to you, like, here's a symbol and here's how you use the symbol. That's what we're doing here. So we've explained like what this does. It undoes that base, and this is the symbol and the notation that we use to do it. So let's go back to our inverse problem. So we had y equals 2 to the x. We switched the x and the y to try to come up with the inverse, but we had this problem in that we did not have any way to get that y out. But now we have a way. We are going to take log base 2 of both sides. The golden rule of algebra still holds. Whatever you do to one side of the equation, you have to do to the other. So I'm going to swap out my colors here and add an extra step. I am going to take log base 2 of x on the left, and I'm going to take log base 2 of 2 to the y on the right. On the left, I just have log base 2 of x. Now over on, I hope I said left there. For some reason, I think I said right, but that's the left. On the right, the log base 2 is undoing this base of 2, and it's going to leave me with just the y. So if my original function was y equals 2 to the x, my inverse function is log base 2 of x. So these are like the pair of functions. So if like one of them is adding, the other one is subtracting. If one of them is multiplying, the other is dividing, squaring, square rooting, exponent, log. It's just another pair of operations. So you've got in that original function this like exponentializing that's happening, and then in the inverse function we have this log that is happening, and they are going to undo each other. All right, so try evaluating some of these on Desmos to check. Now, what I'm going to do up here is I'm going to link a video. So if you're like, I don't know how to use Desmos to do that, click on that link. It's a like 2.5-3 minute video that's going to show you how to use Desmos to evaluate that. Go check out that lesson, come back over here, play with this on your calculator for a hot second, and see what you get. Okay, so I hope that you did that and you did not just wait through the pause. Most of my students would just wait through the pause, but you should go and do it. So if you were to evaluate these on Desmos, you would find that log base 2 of 16 is equal to 4. Log base 2 of 8 is equal to 3. Log base 2 of 4 is equal to 2, log base 2 of 2 is equal to 1, and log base 2 of 1 is equal to 0. And what you should notice is that this is going in the reverse of the original function. So the original function, we took a 4 and the function gave us a 16. In this one, we take a 16 and it gives us a 4. Now you might be wondering, well, how would I do that if I didn't have a calculator? Back in the old days, a lot of like math textbooks, I tell my students this because we do this on the calculator all the time. And some of them kind of have questions about, well, what, could I do this by hand? Could I do this without a calculator? Back in the ancient times, before the year 2000, we had these things called math textbooks, which were super ancient. And in the back of those textbooks, we would have tables, and we'd have like trig tables. But one of the things that would exist in the back of a math textbook was a log table, where you could look up different logarithms. And there was an art to that. It was like one of the lessons your teacher had to teach you was how to use the table to find the values of the logs. Prior to that, you could use, I don't know, a slide rule or something to calculate these things. But basically, these are pretty well-known relationships. You might not know them, but these are things that people have calculated out, and you could look them up. Nowadays, we don't do that. We use a calculator. All right, so this is the exact inverse table of the one that we generated with the function y equals 2 to the x. So this is kind of what I was going through here. If you were to graph y equals log base 2 of x, this is the table that you would get, and that is the exact reverse of the table that we had at the beginning, which is why I wanted to start with the table at the beginning. So here's the function that we used, log base 2 of x, and here's the table. In other words, this will give you the exponent that is I should turn on my pointer there. This will give you the exponent that is needed to generate a particular value. Okay, quick comparison of the graphs. So if you've done the lesson on inverses and graphs of inverses, it is kind of interesting to look at this. It does generate the inverse graphs. So this one up here is y equals 2 to the x, and you can see like some of the points on there. So there's the point 0, 1. There's the point, for some reason I went up to 2, 4. I don't know why I didn't do 1, 2, but like it's there, it's right there. We have the point 3, 8. We have the point 4, 16 on the graph of the logarithm. So this is the graph of the log. You will see the point 1, 0. You'll see the point 4, 2, the point 8, 3, and the point 16, 4, and you can see that symmetry over the line y equals x. So the graphs of these hold to what we know is true of inverses. Okay, so what? We get 16 minutes into this video and it's like, well, that's really great, but like so what? What does this empower us to do? Well, suppose we need to find the value of the exponent that will generate a specific value of y. The log is how we're going to get there. So we have there our original table. So this is the x and this is 2 to the x over here. And the original table had these values in it. And you'll notice that we have like this new value. So in this case, suppose I want to get a 10 out of this. What exponent is going to give me that 10? And you can tell from the table that it's going to be some kind of value between a 3 and a 4 is what the value is going to be. And we could play like guess and check. So we could pick like 3.5 and see how that is, and then go to like 3.25 or 3.75, depending on which direction we need to go. And we could get there. It's a little bit tedious and it's not very efficient. We'd like to have a better way to get there. And the logarithm is how we would do that. Now, if I were a better video maker and I had like a high budget or something, I would know if I put something in this place. But what we're looking at there is like, suppose I have 2 to the x power is equal to 10. And the issue now is, well, how do I get that x out of there? Well, I can do log base 2 of both sides. So I take log base 2 of the left and of the right. And over here, the log base 2 undoes the base 2 on the exponential and is going to leave me with just the x. And so the value of x that will get me a 10 is log base 2 of, be good if I wrote the right thing there, of 10. Okay, so that's what that would be. And then you could leave it like that. If you needed an exact answer, you could grab a calculator. You could look it up on a table to find out, like, well, what number is that as a decimal? And so that is the problem that we have solved there. So let's summarize this, starting with this like generic b to the x equals n. That is our formula that we use to represent exponentials. And in this case, I don't have a specific base. This whole lesson was built around a base of 2, but that base could be something else. It could be a 4, a 5. In a future lesson, we're going to talk about a base of e. Okay, we'll have a video probably introducing what that is as well. But what we're going to do is take log base b of both sides. Again, whatever you do to one side, you do to the other side. As long as you're balancing out like the operations that you're doing on each side of the equal sign, you are good to go. And here's what we've learned in this lesson, that a log of a base will undo the base of the exponential. So this log base b undoes this b here, leaving me with just the x. And so x is equal to log base b of n. General formula, I give it to my students this way: b to the x equals n. The log form is log base b of n is equal to x, but you could use that version of it as well. That's just simply changing the sides there. So you could say b to the x equals n, and x is equal to log base b of n. And a lot of times in my classes, I will just give that to students as like, here's how you change the form. This video is more of an attempt to go back and really look at logs as an operation so that you can see where that formula comes from and why that is effective for finding the value of x. Now, in the next lesson, we will look at solving exponential equations using logs and what that looks like. So please don't forget to give this video a like if you found it helpful, subscribe for more math help, comment to engage. Let me know what questions or comments you have based on this lesson. Does it work with what your teacher is doing or what you've learned before? And hang out on the channel for a while and check out some of our other content. We super appreciate it, and I hope to see you in a future video.